Hello, everyone. Good afternoon. To authors and invited guests, welcome to Technical Session 8D. Myself, Ishita Soran, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference in Smart Trends in Computing and Communications, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being held in a hybrid mode. The physical event was held yesterday in Pune, and the virtual event is being held through Zoom till from the 19th till the 21st of January 2026. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Dr. S. Anupama Kumar, who is an associate professor at RV College of Engineering, India, with over 22 years of teaching experience. Her academic expertise spans computer and society, parallel computing, and data mining, contributing actively to teaching, research, and student development in the field of computer science. We welcome you, ma'am. Ma'am, you are on mute, I believe. Yeah.
Good afternoon.
Good
All the
afternoon,
best
ma'am.
for the participants. I'm also looking for a good session with you all. All the
Yeah.
best.
Thank you, ma'am. Now I'd like to start the paper. We have our first paper presentation, a review on multi-scale pattern learning, dynamic traffic signal control for intelligent urban transportation systems by Saraswati Tomar. Ma'am, if you're ready, then you may start with the presentation.
Uh, can you
Yeah.
confirm that I'm audible?
Yes,
Yes,
ma'am, you're audible.
yes, Saraswati, you're audible.
I've sent the request to share screen.
Yeah, ma'am, please go ahead. You might should be able to share your screen now.
Okay. Is my screen visible?
Yes, ma'am, it is visible.
Okay. Good afternoon, respected session chair, honorable judges, and distinguished delegates. I am Saraswati Tomar, co-author of paper ID 586. On behalf of my team, I am pleased to present our paper, a review paper titled A Review on Multi-Scale Pattern Learning and Dynamic Traffic Signal Control for Intelligent Urban Transportation System. Urbanization is accelerating at an unprecedented rate, and with it, urban traffic congestion has become one of the most critical challenges faced by modern cities. Traffic congestion leads not only to delays and fuel wastage, but also contributes significantly to air pollution and economic loss. Traditional traffic signal systems operate on fixed time schedules, which lack adaptability to real traffic fluctuations and heterogeneous traffic conditions. Such systems fail under peak hours, incidents, and city scale variations. With advances in artificial intelligence and intelligent transportation systems, data driven approaches have emerged for traffic prediction and control. In particular, multi scale traffic pattern learning has gained attention as it can capture both short term and long term spatio-temporal traffic dynamics across different regions. However, despite these advances, most existing models remain primarily forecasting oriented and show limited integration with real time traffic signal control. Hence, this review paper analyzes existing approaches and highlights how multi-scale pattern learning frameworks, especially MTPB, can bridge this gap and move toward intelligent adaptive traffic signal control. Gaps identified. From our detailed study of existing literature, we identified several key gaps, them being most approaches are forecasting focused with minimal direct support for real time signal control. Signal phase and signal state information is not explicitly modeled. Operational deployment challenges are rarely addressed. Model performance heavily depends on high quality spatio-temporal data, limited evaluation on large scale, real world traffic networks. Computational complexity affects real time scalability. These gaps clearly motivate the need for an integrated, scalable, and adaptive framework. Literature review. Now I will explain the literature review funnel, which is central to our review paper. We begin the funnel with traditional and rule based systems, such as microcontroller based traffic lights, fixed time signal switching. These systems offer simplicity but lack prediction and adaptability. Moving upward, we reviewed vision based and IoT driven systems, including YOLO and SORT models using CCTV footage, RFID and IoT based traffic monitoring. These systems enable real time detection but are highly hardware dependent and sensitive to environmental conditions. Next, we analyzed machine learning and deep learning approaches such as CNN LSTM models for traffic flow prediction, statistical ML hybrid models. These improved prediction accuracy but still lacked control integration. Further up the funnel, reinforcement learning based traffic control systems were studied. While RL allows adaptive control, most solutions are simulation only, fail to generalize across cities, require large training data. At the top of the funnel, we reach meta learning and multi scale pattern learning frameworks, especially MTPB. These methods learn universal traffic rhythms, enable cross city transfer, work well under data scarce condition. This funnel clearly shows the evolution from rigid systems to adaptive, transferable, and scalable intelligence, which motivates the focus of our paper. Problem statement. Based on the identified gaps, the core problem is defined as follows. Urban traffic systems exhibit dynamic, non stationary, and heterogeneous patterns that fixed time control systems cannot manage effectively. Existing data driven models focus mainly on traffic forecasting, lack integration with real time signal control, fail to capture multi scale spatio-temporal dependencies, perform poorly in low data and cross city scenarios. Therefore, there is a strong need for an integrated framework that learns multi scale traffic patterns, enables adaptive and intelligent signal traffic control. Proposed solution. The paper discusses a multi-scale traffic pattern learning framework centered around MTPB multi-scale traffic pattern bank. The solution includes multi-scale patch extraction to capture traffic patterns at different temporal resolutions, spatio-temporal transformer architecture for long-range dependency learning, a traffic pattern bank to store and reuse learned patterns, graph reconstruction to model road network topology, meta adaptation to support cross city and low data environments, a bridge to a dynamic traffic signal control enabling future real time deployment. MTPB core idea. The core idea intuition behind MTPB is that traffic follows rhythm universal patterns, irrespective of city size and location. Daily and weekly patterns are predictable and transferable. MTPB learns how these patterns can be transferred from data rich source cities, stores them in a pattern bank, transfers this knowledge to new cities with limited data. The framework consists of training phase, pattern extraction, pattern storage, meta knowledge query for new cities. How MTPB learns traffic patterns. Traffic pattern from multiple cities is broken into multi-scale patches such as 1 hour, 3 hour, 6 hour, 12 hour, 24 hour. Each patch is encoded into a vector using a pattern encoder. Similar traffic patterns are grouped using k-means clustering, forming a pattern bank. A graph representation is used where nodes represent road segments, edges represent connectivity, and adjacency metrics define spatial relationships. This allows the system to learn both spatial and temporal dependencies. How MTPB predicts future? The prediction pipeline follows. In input, we give last 12 hours of speed data per node. Processing, graph reconstruction, short-term prediction using graph wavenet, long-term trend modeling using linear models, meta-knowledge fusion with via MLP. In output, we get traffic speed predictions for the next 36 time steps, that is 3 hours, output stored in CSV format for practical use. Performance comparison. Compared to traditional traffic systems, the MTPB based framework shows higher prediction accuracy, better congestion handling, improved real time monitoring capability, enhanced scalability potential. This validates the effectiveness of multi scale pattern learning over conventional approaches. The paper also outlines clear future directions, integration of real time signal, phase, and state information, fully closed loop signal control using reinforcement learning, large scale real world deployment validation, inclusion of weather events and IoT sensor data, improved computational efficiency, extension to smart parking and emergency vehicle prioritization. In conclusion, this review paper highlights multi-scale pattern learning is a promising direction for intelligent traffic systems. MTPB provides strong generalization and scalability. However, full real-time signal control integration remains an open research area. This paper provides a structured roadmap towards intelligent, adaptive, and sustainable urban traffic management. Thank you for your time and attention. I would be happy to take any questions.
Can you show me your proposed system framework, please? Before this slide, can you just explain me the slide once?
Okay, ma'am.
But
So
wait,
there
I'll
are
tell you. This
four.
is one question I have. Another
Yes.
question I have uh, is this particular pattern suitable to all countries, or are you customizing it for one particular nation?
No, ma'am, it's not particular to one nation. Like the data that we picked up was from multiple countries, from Shanghai and Los Angeles. And when we apply it in local cities, like in India, it can show better performance here as well. So it's not based for one country just. It's about to just recognize the pattern and how that pattern is similar to the new city that we are comparing it to. And using graph reconstruction, we can predict how the new city would perform even when the data is minimal, because obviously for the models we need high data, very large data, but we do not have that. So using MTPB, we can use the data from the uh, data rich cities to the scarce cities.
Okay. Okay, good work. Only concern for me is normally these kinds of frameworks or these kinds of works are very suited for other nations. Can we try something for Indian scenario?
uh,
I know it's a difficult question to answer, but
yes,
still I
ma'am.
thought
Yes.
I'll put a
Uh,
call.
Obviously the infrastructure in India is lacking, like in comparison to US or say Japan, but like the patterns that we see is similar irrespective of the place that we are considering. So maybe the accuracy would fall, but it would still perform better than other systems that we are using.
Okay, fine. We can move to the next presenter, please.
Thank you so much, ma'am.
Thank you, ma'am. We'll be proceeding on with our next paper presenter. I'd like to call upon paper presenter Preeti Sharma with the paper titled E-Governance for Sustainable Industrial Development and Evaluation of State Policies in Uttarakhand. Ma'am, if you're ready, then you may start with the presentation.
Sorry for the interruption, madam. My paper ID is 514. Is it possible for you people to tell me the sequence of my paper?
Sorry, sir.
Paper ID is 514. Is it
Okay.
possible for you people to tell my sequence
Sir,
when I will present my paper?
sir, could you tell me your name, please?
Piyush Gauri.
Yeah, sir. I'll write it to you in the chat box.
Okay. I also write it down into the chat
Yeah.
box.
Do we have Ma'am Preeti Sharma?
Please.
I assume we do not have her yet. I'd like to go ahead with Sir Piyush, with the paper titled Enhancing Resilience in
Yes,
Medical
madam.
Cyber Physical Systems and Exploration of
Yes,
Threats,
madam.
Vulnerabilities, and Countermeasure.
Yeah, yeah. Please wait for 1 minute. I will share my
Yeah, sir.
PowerPoint presentation.
Yeah, sir.
Please wait. Is it visible for all people?
Yes, sir, it is visible.
Very good afternoon to everyone. I am very happy to present my paper, Enhancing Resilience in a MCPS, Medical Cyber Physical System, and Exploration of a Threat, Vulnerability, and Countermeasure. So this paper is totally related to the healthcare. It will become under the healthcare domain, and it is totally related to the medical cyber physical system. And why there is a need to present this paper, because we need to like now the Indian government will present a very nice things related to the national quantum mission. So this thing is totally related with my paper. The national quantum mission is there, quantum computing is there, and how this quantum computing it will be work together with the healthcare domain. So such kind of an ideology is there. So these are by today's content. Introduction is there, major related work with the medical cyber physical system overview, what are the different kind of threats, vulnerabilities, analysis, countermeasure, and conclusion, and future prospect is there. So basically we need to understand uh, what exactly the MCPS. So the backbone, in a background, we need to think about this. It is like an integration of a technology in a healthcare and the development of an MCPS. So it is like an integration. It is like an infrastructure. It is like an security in a healthcare infrastructure. So it will be investigate the complex terrain of a threat, vulnerability, and countermeasure in a MCPS. So that's why we need to uh, our main mechanism, or what exactly we people will examine from this paper. We people will examining a threat facing MCPS. We need to identify what are the different kind of vulnerabilities. We need to identify what are the possible effects on a healthcare infrastructure, and we are looking into efficient defense mechanism and counter measure. So the paper is set out to allow for a comprehensive analysis of this subject. It is related to the threats, vulnerabilities, possible effects. So MCPS, it will be define important idea, and it will be emphasize their importance in a healthcare. We need to explore several dangers that MCPS face, like a malware, threats, cyber attacks, and we people will examine how they affect on data security and patient safety, or how we people will secure when the quantum computer will become into the picture with the healthcare. How we people will secure our software, hardware, and how the human element like social engineering is there. How it will be examined into the medical cyber physical system. So this one is the theme related to the medical cyber physical system. It will be our aim. It will be improve the patient care, simplify the clinical procedure. We need to give the very nice treatment to the patient, and we need to reduce the death rate. So this one is our main important thing. Into the next slide. Uh, there are high level of interconnected medical devices there. They definitely, so these medical devices will be exchange their communication in between device to device, entity to entity, entity to device, organization to organization, hospital to hospital. So these are like an parameters, communication parameter is there. So it will be directly impact on the patient safety, data integrity, or clinical decision making is there. So there are growing cyber threat is there into the healthcare. It is not a new phenomena that the technology has been introduced into the healthcare industry, but in a recent year there has been a exponential growth in this area, like in electronic health record is there, telemedicine platform is there. These are the just two example how technology has become deeply embedded in every aspect of the delivery of a healthcare. So easily we people will understand it is like a seamless integration digital technologies. Our main goal is to improve the patient care, enhance the clinical workflow. We people will support advanced medical research. So again, there are some technology and healthcare convergence is there. It is an increasing interconnection of medical devices day by day. The a software or internet enabled medical devices, it will be comes it into the market. So that's why there is an increasing interconnection of the medical devices. There is an when the internet enabled medical devices, it will become it into the picture. Then definitely the information system is there. Communication network is also grows. So it will be the like continuous data flow across the system and platform. We need to create a new opportunity for smart monitoring, automated treatment, efficient healthcare management, and again, what security is our what main concern. So the objective, our main objective is what we need to investigate both effective countermeasure and defense strategy, as well as to investigate the various threats are currently confronting MCPS, identifying vulnerabilities, and we people will determine the potential impact that these vulnerability could have on healthcare infrastructure. Am I audible to everyone? Hello.
Yes, sir, you're audible.
Yes, yes. So these are our main aims. So this one is what one kind of an figure we need to tell how the real monitoring it will be goes, how the treatment it will be grows, how the cloud it will be there, what are the application is there, and how these infrastructure look like. I will put it into the diagram. These are the treatment. Into the left hand side, doctor is there, electronic health record is there, patient is there, and in between application and treatment the medical cyber physical system is there. There are smart medical devices there, like sensor is there, actuator is there, cloud server is there. So this one is what one kind of an how we need to tell from this diagram how we people will embed in all stages in a healthcare delivery. So real time monitoring, analysis, response are made possible through this convergence of the digital and physical infrastructure, which is the concept of cyber physical interaction, and which is at the core of medical computerized patient monitoring system. So this integration from this diagram, we people will easily understand what exactly the integration is there. So this integration provides healthcare provider with actionable insights, which enable like interventions is there. Personalized care is to be provided. Intervention is also there. Timely intervention is also there. So by transcending the boundaries of a traditional healthcare, uh, we need to provide a security mechanism related to this. So this one is nothing but the one kind of an architecture. MCPS, it enables a real-time patient monitoring system. What exactly the purpose of the study, or what is the purpose of this paper? It will improve the security and resilience of healthcare system, address evolving cyber threats, examining the interaction of technology, human factor, regularity requirement is there if the doctor need to treat the patient. So these are the coming under the mechanism of an regulatory requirement. So this paper structure it will be tells us the overview of a MCPS analysis of an cyber attack. So these are the infrastructure, but into that infrastructure, which kind of an threats, vulnerability, malware, inside threats, we need to elaborate such kind of an mechanism, and we need to develop such kind of an infrastructure. It will be totally secure, it will be totally scalable, and it will be totally under the prevention mechanism. Only to provide a security it is good, but to provide the prevention mechanism is also very important into this paper. So the study of MCPS vulnerability is there, software flaw is there, hardware weakness is there, human factor, social engineering is there. So these are the impacts of an cyber attack: economic consequences, operational disruption, use case studies also there, real world healthcare. Then demonstrate how the severity of threat is there. We need to highlight need of preventive security measures. Defense and countermeasure is there, prevention. Authentication mechanism is there. Mutual identity establishment mechanism is also there. Data encryption, access control, detection and response. So this one is nothing but what I already explained. What exactly we need to enable? We need to enable the advanced patient monitoring, accurate diagnosis, intelligent treatment delivery, and security and privacy is also important. Threat identification is there. We people will focusing on the threat identification, attack detection, security solution, and remedies. Am I audible to everyone? Hello.
Yes, sir, you are.
Yes, yes. So these are the key findings. What exactly available into this paper? These are the key findings. MCPS application in smart healthcare, machine learning and IoT based MCPS architecture is there. Cyber threat and attack path analysis. There are different kind of an path identification and path analysis is there. So these are coming under the under the area of discrete mathematics. How the path analysis is there, discrete mathematics and networking is there. So major security concern is identified. Our this one is our main focus: cyber attacks, vulnerability, data privacy, integrity risk, machine learning model, exploitation. Okay. So key contribution, need for intrusion detection system. We need to identify, because we need to, whatever the threats is there, whatever the vulnerability is there, whatever the attack is there, first of all we need to understand what exactly the nature of the threat, what exactly the nature of vulnerability is, what exactly the nature of an attack. Then and then it is possible for us to provide the very good infrastructure secure mechanism to the medical cyber physical system. So this one is nothing but the research gap available. We strongly need comprehensive security framework. We need real-time intrusion detection system. We need secure and scalable data sharing protocol. We need to emerging technologies. Blockchain is there. Blockchain is very good for the data integrity and access control, because it has itself has a distributed inner nature. For the authentication mechanism, also blockchain, it will help us. So this one is nothing but the open challenge for us: scalability, integration with the various kind of a healthcare system with internet enabled healthcare devices, and integration with this one is also what an open challenge. Balancing security is there, usability is there, patient safety is also there. Addressing this gap will help HCPS to realize their full potential, transforming healthcare. So healthcare faces a complex and evolving cyber threat landscape. MCPS is the primary target or prime target due to the sensitive patient data, critical life dependent medical data. Major threat resources are cyber criminal threat, human errors. So common attack scenario we need to understand. There are different kind of an attack is there. We people will introduce one attack, ransomware attack is there. We people will encrypt the medical data, disrupt healthcare device. Data breaches is there. System manipulation is also there. There is the possibility to tampering with the medical devices and software, altering a treatment protocol and patient data. So network MCPS increase the attack surface. Major risk is also there: operational disruption, data confidentiality, patient safety. There is the key security concern: unauthorized access to device and network. So for this purpose, we people are using the quantum key distribution. We are not providing any kind of an unauthorized access. There is a lack of real-time threat detection is there. So by using the QKD, real-time threat detection is also there. This lacuna we people will remove it because of the quantum key distribution. Mitigation and research direction is there. Code protection, secure software design, network encryption, user training, anomaly detection, traffic monitoring. So these are the emerging research. Machine learning is there. So these are the vulnerability. What is our main aim to the paper? We need to tell so which kind of a weakness is available with the medical cyber physical system. So like, and we people are explaining software vulnerability. So the what exactly the software vulnerability in the MCPS? These refer to weakness or flaws in a software application, or it is also possible for us to find out the vulnerabilities or flaws available into the operating system. Like I will give you the one kind of an example. What
Excuse
how
me,
it is
sir.
possible? Yes, madam.
I'm really sorry to disturb you, but I'd like to remind you of the time limit.
Yes, yes, yes. Within
Yeah.
1 minute, I will cover up all the things. So only I will give you the very small example how to find out the flaws and vulnerabilities in the operating system. हम लोगों ने बहुत बार देखा, lots of the time we people are discussing about the deadlock. The resources is less, but user is very in a large scale, but resources is less. That time deadlock is there. Then it is very easy for us to find out the bugs, flaws into the software. So because of this medical cyber physical system and quantum computing system, it is very easy for us to provide the very good infrastructure. And in infrastructure, it will be also cover the parameter like security, like prevention mechanism, like detection mechanism. So detection is not our main aim. Our main aim is what? Prevention. So these are the vulnerability. Hardware vulnerability is also there. Affected device, infusion pump risk is also there. Okay. So these are some kind of vulnerability. Human factor and social engineering is also there. Social engineering attack, phishing emails, potential impact is there. Mitigation strategy is also there. So MCPs face various growing cyber threats impacting patient safety, data integrity, continuity. Key vulnerability is also there. It will be arises because of the software flaw. Just I said I already given the example related to the operating system. Hardware weakness is there. Cyber attack is also caused because of the operational disruption. Financial loss is there. Legal and ethical consequences is there. So these are the references. Thank you very much. So because of this paper, it is very easy for us to find out the risk, threats, vulnerabilities, attacks, and we people will provide a good infrastructure with the medical cyber physical system, and we people will connect this medical cyber physical system with the quantum computing. Thank you very much. Hello, am I audible? Hello, hello.
Yes, sir, you're audible. Yes,
Yes,
sir, you're audible.
yes.
Ma'am, would you like to ask any question?
Yeah. So can you go back to your slides, please?
Slide
I
3,
want.
na?
Yeah, I want to see your proposed solutions you are giving. I just wanted to see that once. Yeah.
Yes, this one is the proposed methodology.
Yeah, sir. So have you worked on this and you've got some experimental results out of this?
Yes, definitely. I got some experimental result from this. I'm very happy to tell you, madam, to understand this proposed methodology. I write it down very theoretically in this my PowerPoint presentation. But to understand the threats or to understand the cyber attacks or to understand the various different kinds of an attack, I already use the discrete mathematics over there in my next
Okay.
paper. Discrete mathematics is there, and because of the discrete mathematics I made some rules related to the attacks, and
Okay.
because of these rule it is very easy for me to understand the nature of the attack. जैसे human का
Okay.
nature is also there, likewise threats का nature is also there, vulnerability का nature is also there, attack का nature is also there. So because of this discrete mathematics rule, whatever the rule I created, 12 rule is there I created, and because of this 12 rule it is very easy for me to understand the nature of an attack, and because of this nature it is very easy for me to prevent these attacks, because I am telling this nature to my infrastructure कि देखिए कि such kind of a nature is coming, then you please identify this one is the threat, this one is the vulnerability, this one is the attack, then stop the communication in between the sender and receiver.
Right. You could have put when I felt, so only I asked. Okay, sir, fine. Thank
Yes,
you.
yes, madam. Yes. Shall I stop my presentation, madam?
Yeah, sir, you can.
Any
Thank you for
input,
your
madam?
valuable
Any
presence,
input
sir.
from your side?
No, sir, none
No,
as
sir.
such.
Actually,
Thank you.
I thought of seeing the results if you have done. That's it. No other input.
Yes,
Since you have already started working. Good.
yes. I already started working. In my next paper, in my next presentation, all these things it will be interconnected. Thank you, madam.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presentation. I'd like to call upon paper presenter Gurju Dinesh Babu with the paper titled Hybrid Quantum Classical Learning for Oral Cancer Image Classification. Sir, if you're ready, then you may start with the presentation.
Yeah, ma'am.
Yeah.
Can I start, ma'am?
Yeah, sir, please go ahead.
Yeah. Yeah. Okay, thank you, ma'am. First of all, thank you for giving me this opportunity to present my paper. My paper title is Hybrid Quantum Classical Learning for Oral Cancer Image Classification. And we are combining classical deep learning and quantum computing to improve oral cancer detection from medical images. And this work focuses to improve early oral cancer detection by combining classical deep learning with quantum computing. As early diagnosis plays a crucial role in increasing patient survival rates, and oral cancer is often detected in advanced stages due to subtle visual differences in early lesson, which motivates to need of more powerful AI-based diagnosis systems. And this work was presented at the SMARTCOM 2026, and our goal is early cancer detection using next generation AI technologies. And today in this presentation, I will first introduce the concept of hybrid quantum classical learning, and then explain why oral cancer detection is important, show how quantum computing offers a solution, and I will then highlight our key research contribution and describe the data set and preparation methods, and explain the classical dense net baselines, and present our proposed hybrid architecture and quantum neural network designs, and finally conclude that with results and performance analysis. And this is the introduction for hybrid quantum classical learning introduction. Here, first, I would like to introduce the concept of hybrid quantum classical learning. In simple terms, this approach combines classical deep learning models with quantum computing techniques. And classical neural networks such as visual features from images, and however, they have certain limitations when dealing with very complex and subtle patterns. To overcome particular this issue, integrated quantum component. Quantum component uses principles like superposition and entanglement, which allow the data to represent much richer future space. In our work, quantum part does not replace AI, but it acts as a complementary learning layer that enhances future transformation and representation here. And coming to next, let us understand why only oral cancer detection is so important. Here, oral cancer is one of the most common cancers in developing regions, and unfortunately, most cases are diagnosed at advanced stage. This late detection reduces survival rate, and early stage oral cancer lesions are visually very subtle and often look similar benign conditions, which makes a manual diagnosis very difficult. If we detected early, the 5-year survival rate increases from around 30 to 40% to more than 80%. And therefore, this is a strong need for accurate and automated and reliable AI-based diagnosis systems here. And coming to here, limitations of existing AI systems. Most current medical image classifications models rely on convolutional neural networks with a fixed convolution filters. These filters are limited in their ability to capture highly complex and nonlinear relationships. Is it audible, my voice?
Yes, sir, it is audible.
Yes, you are audible, sir.
Yeah. Additionally, yeah, okay. Classical deep learning models struggles with a high dimensional feature interaction. Especially when the data sets small and data set is small or else imbalance data set, which is very common in medical imaging. So even data augmentation and transfer learning, these models reach performance ceiling on fail to capture extremely subtle patterns and required for. Yeah. Now I will briefly highlight the key contributions of our work. And we proposed a novel hybrid quantum classical learning framework, and specifically for oral cancer image classification. Here we integrate a lightweight classical network, a mobile net V3, and with a variational quantum circuit here. That means a hybrid framework and integrated architecture. And we after that we perform as a performance benchmarking. And here, benchmark our approach against a strong classical baseline and dense 121 and achieved better performance with reduces training complexity here. And one of the most importantly, our model is designed to work on near-term quantum systems, making it a practical and it will be very feasible here. And coming to moving on to the next one, next slide, dataset and preparation. We use a publicly available oral cancer images dataset platform that is at Kaggle and consisting here cancerous images and non-cancerous images. And to improve generalization, we applied image pre-processing techniques such as resizing and normalization, and data augmentation methods like rotation and flipping and zooming and brightness adjustment were used. And here Class balancer was handled using class weighting, and the data set was split into training and validation and testing sets here. And coming to before introducing our hybrid model, we established a classical baseline using DenseNet 121 here. DenseNet 121 is widely used medical imaging guide. It is dense connectivity, which promotes future reuse and improves gradient flow. And here, this architecture follows standard pipeline of future extraction and global average pooling and sigmoid equation for classification. That means when which one is a cancerous and which one is a non-cancerous images. And however, despite this strength, DenseNet 121 has limited representation flexibility when dealing with subtle early stage oral cancer patterns here. And now this is the I will explain. This is a proposed hybrid model architecture here. Now I will explain our proposed hybrid architecture. The input oral cancer image was first passed through the mobile net V3, and which efficiently extract relevant features with low computational cost. And these features are then compressed to reduce the dimensionality. And the next compressed features are fed into variational quantum circuit, and where quantum operations transfer the uh, features into richer representation. And finally, classical classifier produces a predictions, and this hybrid designs such a high accuracy, remaining computational efficiency here. So high accuracy with low computational cost, ideal for the deployment. This is a final outcome of this model here. And coming to here, let me briefly explain the quantum neural network design. Our variational quantum circuit uses 8 qubits, and classical features are encoded with the quantum states using angle embedding. Quantum states using angle embedding trainable quantum gates, so that is rotational X and rotational Y and rotational Z. Allows these circuits to learn optimal transformations here. And entanglement layers captures complex nonlinear feature interactions, and the circuit depth kept reduce the noise here. And the quantum layers functions are nonlinear feature transformer, and it is compatible with the current noise intermediate scale quantum era quantum devices here. And the final advantage of this is a nonlinear and entanglement representation for superior future extractions only here. And finally, these are the result performance analysis. These are the metric evaluation, that is a phone score and recall and precision and accuracy. Here, finally, coming to these results, the classical dense 121 model achieved accuracy of 92.5%. In contrast, our proposed hybrid quantum classical model achieved accuracy of 96.2% here. So here the significant 3.7% accuracy gain with hybrid model here. This is the advantage of this hybrid model. And coming to a conclusion, this performance demonstration and the future achieving the 96.2% accuracy. The proposed model demonstration that quantum assisted learning and uncover subtle patterns critical for early diagnosis. So this work highlights the hybrid of AI systems and real world medical applications. Thank you for your patience. And are there any
Sir, do
questions?
we have any doctor who is working with you and verifying your results? Since it's healthcare data,
Yeah,
I feel that
yes.
is very important for us to get it verified from a domain knowledge person. And
Yeah,
what
she's working.
are the different ways you are going to
Yeah,
apply to improvise this accuracy?
yeah, yes. So when compared to classical model, the hybrid model proposal is to increase accuracy and to get predictions in more accurately. So that's the purpose of we using this quantum model. I mean, hybrid quantum model. Yeah.
Thank you, sir. We'll be proceeding on with our next paper presenter.
Okay,
I'd like to call upon our next presenter, Jaya Chitranshi, with the paper titled Immersive Virtual Environments, an Inclusive Virtual Reality Tool for Improving Mental Health and Well-Being. Ma'am, if you're ready, then you may start with the presentation.
Good afternoon, all. I'll be sharing my screen. I hope the screen is visible.
Yes, ma'am.
Yes, ma'am, it is visible.
So this is paper ID 829. The title of the paper is Immersive Virtual Environments and Inclusive Virtual Reality Tool for Improving Mental Health and Well-Being. So the authors of this paper are Jaya Chitranshi, Reena Lenka, Kiran Kakde, Rohit Bakshi, and Devina Srivastava. The first four authors are part of Symbiosis Institute of Management Studies, Symbiosis International Deemed University, while the fifth one is a trainee solicitor working in a global law firm in its London office. So here is a brief introduction of the topic and the study. The study focuses on certain variables. The first one is immersive virtual environments. So immersive and inclusive virtual worlds, they have a great deal of promise as a tool for mindfulness-based interventions that are aimed at enhancing mental health of people, enhancing the therapeutic experience, and expanding the reach of mindfulness interventions to a wide range of individuals. Immersive virtual environments, or IVEs, provide new ways to practice mindfulness by constructing an immersive and captivating adaptable environment. Optimizing the planning, execution, and assessment of immersive virtual environments based mindfulness programs should be the main goal of future research and development initiatives in order to fully realize the benefits of these programs for improving mental health and well-being. So in this background, where there is a lot of focus on virtual environments, we are trying to connect that, to connect this concept to the mindfulness-based interventions for the effectiveness of such interventions. This paper explores how immersive virtual environments, which is a virtual reality application, can revolutionize mindfulness-based interventions. So with this in mind, the objective of the paper, as we have just discussed, is this paper is a review-based study, and it tries to look into how mindfulness-based treatments or interventions, which are known as MBIs, for stress reduction and mental health promotion, can incorporate immersive virtual environments, or IVEs. The paper investigates how virtual reality-based technologies can improve effectiveness of MBIs, or mindfulness-based interventions, through research and analysis, providing deep insights into mindfulness practices in the virtual environments. Here is a brief of the methodology of this paper. The paper integrates findings from 64 articles that have been published between 2016 and 2025, because the concept of virtual environments is relatively new, except there is one paper from 1990s, as it was about the theory building from contemporary psychology. A systematic review approach was adopted in this paper. The approach focused on studies related to virtual reality applications in mindfulness, stress management, and emotional well-being, as all of these are connected with the mental health and well-being. Certain key databases like Scopus, Web of Science, etc. were used to get a comprehensive coverage of interdisciplinary research that has happened in these areas of virtual environments and mindfulness-based interventions. Thematic analysis was done to identify major themes of virtual reality-based mindfulness interventions, and their impact was also seen on mental health with the help of thematic analysis only. A model framework was also developed to understand the dynamics of immersive and inclusive virtual environments in mindfulness-based interventions. So here is a brief of the literature review that has been done. Basically, most of the researchers, they focus a lot on the future as it is unfolding, where there is a lot of focus on virtual reality tools. So Riva et al. In 2020 they highlighted that virtual reality based interventions can be tailored as per the individual patient's needs, and just a second. And certain other device, and these devices will be available in future. So this was done in 2020. Practice sessions from remote locations can be attended via the online mode if needed. That is taken from a study by Gull et al. In 2023. In addition to the technological barriers like cyber sickness, which was pointed out by Bouchard et al. In 2017, there are certain ethical concerns like data privacy, bad impact of prolonged use of such devices, etc. Research has also provided that immersive virtual environments influence the effectiveness of mindfulness-based intervention in a positive way, making them more engaging and distraction-free for mindfulness-based practices. Such environments can stimulate the senses and can easily the senses can get relaxed, the subject can get relaxed and calm, as per Benos et al. In 2017. A study by Padma Priya et al. In 2025, the study explored the potential of VR and AR in the healthcare sector. The authors focused on patient treatment, training, stress training, and health education, etc. They highlighted that VR and AR do influence patient outcomes and contribute to augmented well-being in the healthcare sector. Singh and Connert in 2025 studied the therapeutic uses of AR and VR in the field of mental health. They focused on evaluating the potential of AR and VR in influencing and revolutionizing the traditional treatment method to improve patient outcomes. Ghoshal et al. In 2024, they also highlighted that virtual reality supports mindfulness practice and reduces type 2 diabetes related stress. So if we try to understand the literature that is existing, that clearly identifies the need of a model or a framework that can combine VR interventions with certain medical health or well-being related outcomes. So on the basis, so this was just a brief of the of some of the studies that have contributed to this article, and so here are the results of this study. So the table shows thematic analysis of immersive virtual environments, and we can see that the two themes that have been identified are on this slide: enhanced engagement through virtual immersive environment. And we can see the key findings of the article, like mindfulness and meditation in VR scenarios resulted in lowered anxiety, heart rates, and muscle activity. Participants completed VR mindfulness programs 40% more than traditional programs. And VR enhanced psychological presence and handling of emotions. VR interventions had a 25% higher completion rate because of engaging participants. VR increased focus, decreased distractions, and reduced anxiety. And so the theme was enhanced engagement through virtual immersive environments. The second theme was positive impact on mental health metrics. So 30% improvement in anxiety scores with VR-based mindfulness trainings was observed. Improvement in anxiety scores means reducing of anxiety. VR-based mindfulness in students reduced exam-related stress and improved emotional regulation more as compared to screen-based mindfulness. Post VR-based mindfulness sessions, a 25% reduction in stress and anxiety was reported. VR-based mindfulness as compared to audio mindfulness sessions reduced anxiety and stress. VR-based mindfulness reduced depression and anxiety in older adults and people with mobility issues. The third theme was broader accessibility to vulnerable groups. So it was seen that VR-based mindfulness improved emotional regulation and stress response. VR-based mindfulness reached the rural and the physically handicapped folks, helping in reducing stress, and VR-based mindfulness reduced stress and anxiety of children undergoing surgery. So based on this, a model was developed which says that VR-based mindfulness, if you are using this, which is a VR-based mindfulness is a combination of virtual reality with mindfulness interventions. So it results in enhanced engagement, positive mental health outcomes, accessibility and inclusion, and mental health regulation. And this is important for holistic well-being of employee, of people or patients. So this slide shows different kinds of mindfulness based interventions and their benefits. So mindfulness based interventions can use immersive virtual environments, and they can also can be combined with mental health and well-being, and this will result in enhanced engagement through immersion, positive mental health metrics, measurable mental health benefits, widened accessibility, enhanced regulation of emotions, cost effectiveness, controls. This will control anxiety and stress because everything is happening in a virtual mode. This will, in terms of mental health and well-being, this will bring in more satisfaction, improve performance, improve productivity, will help in forming social circles, will help in interrelationships, and will bring in and will help patients or individuals in terms of emotional resilience. So to conclude, immersive virtual environments are going to represent a paradigm shift in the mindfulness based interventions. This will offer scalable, engaging, and effective tools for improving mental health and well being of employees or of individuals. Various challenges, there are various challenges like the integration of virtual reality tools into into mental health strategies. This holds immense promise for future, but it is challenging. This will surely pave the way for innovative therapeutic treatment. Also, research and collaborations across disciplines are extremely necessary to harness the full potential of this transformative technology. There are certain implications also. Virtual reality should be combined with cognitive and behavioral approaches for anxiety patients. Otherwise, there can be serious implications. VR environments can be changed as per the real-time individual needs, enhancing engagement. Gamification can be used. For example, like certain challenges, feedback loops, and rewards, etc., can be woven into this metrics. And long-term effectiveness of VR-based mindfulness approaches are yet to be studied, which means beyond the short-term or single-session interventions, we should look into the long-term interventions. Thank you. Should I stop sharing?
Can I see your proposed system once, please? Not your results. I want your proposed system.
This one?
Yeah. Now, come back to your results now. This system is entirely, you want to build it using AR, VR techniques, right?
Yeah.
VR techniques you want to build. What?
Into mindfulness-based interventions only.
Correct.
And health, mental health.
Correct. Now, how do you think this is feasible in Indian healthcare scenario to do? I'm just out of curiosity, I'm asking. If I want to put all these things into a hospital, how is this going to be feasible for us?
Ma'am, as far as I understand, such virtual reality tools are going to be the future of any therapeutic study or any therapeutic program.
Correct.
That the hospital is offering, because they will have.
I agree to you, because this is going to be, it's already there in many of the foreign countries, and still it's like a baby step in India.
Yeah.
We have not seen it, correct. So I'm just thinking, looking at the population in India, looking at the urban and rural populations in India, we as engineers or we as technical people, we are proposing many solutions. But how far it is going to be financially Please, have you just put a thought on it? It's only a
That
discussion
is
between
because this technology is costly and but it is very useful and uh, because the person actually is in a virtual world and somehow the treatment is actually taking place there. So all therapies are taking place there, for example group therapy and stress therapy, so all of that, or play therapy, so all that is happening in the virtual environment. So though the technique is the tools will be very costly, but if hospitals use they are using such tools, then this will help, this will actually change, bring in a paradigm shift. Because I have seen other countries, they are using virtual reality tools even in tourism. So if even in the tourism sector they are using it.
even in
So
colleges
mental health is something much more important than tourism.
because we have a couple of projects which students use in schools, students use in healthcare for children who have other behavioral aspects or other things. But that's what I was just thinking financially how this can be feasible. That's it. That's my only concern to think.
Yeah,
Thank you.
because
Thank you.
the technique will be costly, so maybe some
Very
sponsorships or
costly.
some support is needed for hospitals also, so that they can have such systems. And this will be especially helpful for people with disabilities.
Yes, ma'am. Thank you.
Yeah, for them this will be really helpful. Thank you, ma'am.
Thank you, ma'am. I'd like to call upon our next presenter. We have Sushmita S. with the paper titled Integrating Blockchain and Deep in Reinforcement Learning for Secure Drug Traceability and Inventory Management in the Pharmaceutical Supply Chain. Ma'am, if you're ready, then you may start with the presentation.
Yes, I'll share my screen. Am I audible?
Yes, ma'am, you're audible.
So good afternoon to one and all present here. I am Sushmita and I'll be presenting our work integrating blockchain and deep reinforcement learning for secure drug traceability and inventory management in the pharmaceutical supply chain. This work focuses on addressing both drug authenticity and intelligent inventory decision making. This is the outline of my presentation. I'll begin with the problem statement and research gap, followed by the proposed system and architecture. Then I'll explain the blockchain-based traceability and the AI-based inventory optimization using deep reinforcement learning. Finally, I'll discuss the results, conclusion, and future scope. The pharmaceutical supply chain faces two major challenges. First, the presence of counterfeit and tampered drugs, which poses serious risk to the patient's safety. Second is the inefficient inventory management, which leads to frequent stockouts or excessive wastage due to drug expiry. The traditional systems treat traceability and inventory management as separate problems, which limit the overall efficiency. Now let's look at the research gap. Existing solutions either focus on blockchain traceability without inventory management or on demand forecasting without secure supply chain integration. There is a clear research gap in combining both secure traceability with adaptive learning-based inventory optimization. This motivated us to create a unified supply chain framework combining both traceability and intelligent inventory decision making. The proposed solution. So we are using blockchain for immutable drug traceability. The IPFS is being used for decentralized and tamper-proof document storage, which stores the regulatory documents of the chain. And the ensemble forecasting is used for the accurate demand prediction, and deep reinforcement learning for the adaptive inventory optimization, which adapts to the fluctuating demand patterns. This gives the overview of our overall system architecture. So in the layer 1, we have the different drug supply chain entities which store their drug data onto the blockchain infrastructure. And the IPFS is used for off-the-chain document storage. And in the layer 4, pharmacy uses AI-driven inventory optimization using deep queue network in order to find the reorder decisions. All these layers interact using the RESTful APIs, and security and compliance is being ensured through cryptographic hashes, digital signatures, and role-based access control. Let us look at each of these layers in detail. First is the supply chain and blockchain layer. This is being implemented using Hyperledger Fabric, which is a permission blockchain network which uses private channels and membership service providers. This gives permissioned access for each of the authenticated identities with the help of role-based access control. And all the records once stored on blockchain is immutable and ensures security. The smart contract design. The smart contract is being implemented using the Go language, and each drug batch here is represented as a blockchain asset. And the key operations over here are the drug registration. The manufacturer is the person who will register the drug. Ownership transfer. Here we have defined the rule for transfer of ownership. It happens in a sequence from manufacturers, then to wholesaler and distributor, then comes the pharmacy. No one in between without the transferred ownership to them will be able to make any changes in the blockchain. Drug verification. The pharmacy will be able to verify the movement of the drugs with the help of the batch ID. Recall management. This is a feature which is enabled for the manufacturers. So if they find any discrepancy in the drug, they can recall it from moving forward in the blockchain. And next is the transaction history tracking, where we can track the entire movement of the drugs from its first stage of manufacturing till the current state. So every status update or location update that is taking place will be able to track over here along with the timestamp of when it happened. IPFS document storage. So this storing all the documents like test reports directly on the blockchain is inefficient. So we store all the documents off the chain using IPFS, and the content-based hashes is being linked and stored onto the blockchain. So this ensures both document integrity as well as tamper resistance while reducing the storage overhead onto the blockchain. The pharmacy interface and data flow. So the pharmacy can actually enter the batch ID and verify the drug authenticity. Once they enter the batch ID, they will be able to look at the complete drug lifecycle history of every transaction that took place. And they have the real-time sales data on daily basis of the pharmacy, which they feed into the inventory optimization module, which uses deep queue network in order to give the reorder decisions. Now let's look at the AI-based inventory optimization. This is the most important part of the intelligent inventory decision making. Here a state is being maintained, which includes the historical sales, the sales data of the drug which happened in the past months, the estimated demand. This is being getting from both the ensemble forecasting along with the neural network estimate, and the available inventory, which is the inventory that is being present currently after the sales took place, and the expiring stock, which is going to be expired soon. And the action of this is the optimal reorder quantity. So reward penalizes both stockouts and excess inventory. So the reward is a major part which enables this. So we heavily penalize the stockouts as stockouts directly affect the patient's safety. So we give negative penalty to the stockouts, and if there is a controlled overstock within a particular limit, then it is being accepted as a safety buffer. And when there is an excessive overstock that is being taking place, it is again given a negative penalty. So this helps in minimizing the overstock and penalizes the stockout completely, helping in balancing both and giving a safety buffer in case of emergencies. Now let's look at the methodology. So the pharmacy collects the sales data, and this is being fed into the ensemble model in order to give the demand forecast. The DRL agent then determines the reorder quantity of the drugs, and the inventory is being updated dynamically. So this creates a secured closed loop, which helps in both traceability and adaptive inventory optimization. So the results that we obtained through this is that there was 0% stockouts, and the overstock rate was from 4 to 7%. And we used MAPE for forecasting accuracy, which was from 3.9 to 6.9%. And we were able to achieve 100% traceability, as all the drugs were being able to trace from the manufacturing till its current state. So compared to the existing system, our system lowered the wastage, there was no stockouts, and it provided complete transparency. So this shows that DRL adapts effectively to changing demand patterns, blockchain ensures traceability, and IPFS is used to prevent the document manipulation. So all these together improves the operational efficiency and the safety of our system. So the future work is we can include IoT-based storage condition monitoring for the drugs and explainable DRL models, which can explain the users for every action it takes, and hospital level deployment. These are the references that we used for our paper. Thank you.
Thank you, Sushmita ma'am. Thank you.
Can I stop sharing, ma'am?
Yeah, sure.
Yes, ma'am.
Thank you.
Presentation was good. Thank you.
Thank you.
Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon paper presenter. One second. Jaya Chitranshi with the paper titled Integration of Performance Management System with Learning and Development for Employee Retention. Ma'am, if you're ready, then you may start with the presentation.
Yes.
Yeah.
Yeah, so I'll share my screen.
Sure, ma'am.
I hope the screen is visible.
Yes, ma'am, it is visible.
So the paper ID is 801 and the title is Integration of Performance Management System with Learning and Development for Employee Retention. The authors of this paper are Jaya Chitranshi, Zainab Chhatriwala, Reena Lenka, and Vanishri Pabalkar. All four of us are associated with Symbiosis Institute of Management Studies, Symbiosis International Deemed University, Pune. Here is a brief introduction about the topic. Organizations of today are surviving and competing with other organizations in a VUCA environment. This environment is characterized by volatility, uncertainty, complexity, and ambiguity, and this is rising every other day. Organizations thrive and succeed in this VUCA environment because of their high performing employees. An organization needs a skilled and highly engaged workforce to perform in this environment. Otherwise, it will be very difficult for the organization to even sustain in this environment. Identifying such high potential employees and encouraging them to work for the organizational goals is possible only when the organization has in place a fair and smooth PMS or performance management system that is aligned with the reward function of the organization. To assist an employee to perform to his best potential, a learning and development function also needs to be attached to the PMS or should exist alongside the PMS of the organization. This learning system makes an employee equipped with necessary skills to perform the desired role. Employee retention will depend on how well the organization has merged the two functions of performance management and learning and development for employee growth and welfare. This study looks at the PMS of some of the organizations. So we had taken two organizations, ORG1 and ORG2, alongside other PMS literature that is available. and their existing practices, the existing practices of these two organizations, to design a new system that evaluates employees on different aspects. The proposed PMS also ties in with the learning and development aspect of the organization. So that is the purpose of this paper. So as we have discussed, the objective of this paper is to propose a new performance management system that takes into account the current performance of an employee alongside taking the potential capabilities of the employee during a performance evaluation process. Methodology that was adopted for this study. So this study conducted a critical review of related literature and content analysis to determine the basis on which different PMSs are evaluated in relationship to their effectiveness. Data from three major databases was used: Scopus, Web of Science, and Google Scholar. This methodological review aimed at critically analyzing the literature that has been established on performance management system and their efficiency in organizations such as ORG1 and ORG2. So the literature was matched with the organizations that were under study. This review made use of a systematic framework which includes a critical literature analysis and content analysis to derive the basic elements that drive the judgment of PMS. Here is only a brief of the literature review that was done for the paper, because the focus of this paper is on developing a framework. So in a nutshell, the literature shows that appraisal systems play a very crucial role in organizational success and development of employees. Thus, training, feedback, and competency mapping are undertaken in organizations to enhance performance management practices. With these remedial measures and an all-inclusive appraisal system, with the recognition of value employees' potential brings to them, it is expected that individual performance will be developed and consequently organizational effectiveness will be enhanced positively. Future studies should continue to search for new appraisal models that fulfill these objectives. So this is the summary of the literature that was studied, and this is a field that is fast emerging, and this is fast evolving and fast changing also. So every other year or every a new the PMS that is in existence in an organization should change as per the changing atmosphere. So here are the results of this study. So ORG1 is a major fast-moving consumer goods company, FMCG, a subsidiary of a UK-based company. This company is known to be a pioneer when it comes to HR initiatives. The company follows 360-degree appraisal process where all the major stakeholders that are associated with the role, their feedback is taken for the performance review. This organization is using management my objectives, which is an approach that was given by Peter Drucker. Through MBO, the organizational goals are reviewed first, and then employee objectives are formulated. Then the employee is monitored, the employee is evaluated, and finally the employee is rewarded. So his performance is actually focused on certain objectives, key objectives. The PMS process at this organization, as captured by Kumar 2019, is as follows: establishment of a performance standard expected from the employees, communication of the set standard to the employees, measurement of actual performance against the set target, compare the employees' actual performance with the set standards, figure out the deviation between the two, make suggestions in terms of change in the job analysis and standards if necessary, and doing periodic follow-up. In the second organization, which is a UK-based confectionery company, this organization introduced the 720-degree feedback system. This new format includes collecting feedback from various business stakeholders like subordinates. There are 2 rounds of feedback in the 720-degree feedback. So if we combine 360-degree twice, we will get 720. It consists of twice, or even if we combine it more than twice, that is also known as 720 only. It consists of the following dimensions: Pre-appraisal feedback. This feedback is collected from various stakeholders that the employee is expected to have or worked with or interacted with. The performance of the employee is evaluated first, then accordingly the goals and targets are set. So this is pre-appraisal feedback. Then self-appraisal. The employee does a self-assessment of their performance and how well did they manage to achieve their targets. Peer appraisal. Feedback is collected from fellow team members of the employee. Customer appraisal. Customers offer feedback on the employees based on their experience working with them. Subordinate appraisal. The subordinates of the employee give feedback about them. This is important to understand the team dynamics. Manager's appraisal. The employee is rated by their manager on how well they performed and their achievements against their set targets. Then post appraisal feedback is also there. This aspect is what differentiates the 720-degree appraisal from the 360-degree appraisal. Here the actual performance of the employee is assessment against the goals set during the pre-appraisal period, pre-appraisal feedback stage. So we are combining the two performances. So this was for organization 2, 720-degree performance appraisal, self, peers, managers, and customers, subordinates, pre-feedback, and post-feedback. So this is the reason why they are calling it 720-degree when you are moving above 360-degree appraisal. So this is the proposed PMS based on these two organizations and based on the literature that is available and the key features and the PMSs that have been discussed in literature. On that basis, this is developed. The first stage is establish performance evaluation framework. So establishing performance evaluation framework is the first stage. You have to start from there. Decide evaluation frequency. The frequency of performance evaluation within a company needs to be decided by the management. There would be biannual, either that will be biannual performance appraisal process, or they can have annual also. That would take place in months of March and then in September if it is biannual. Evaluation methods, a combination of both quantitative metrics like sales targets, customer services scores, and qualitative assessments like leadership qualities, teamwork, etc. can be used to rate each employee within the organization. Here, key result areas or key performance indicators, KRAs and KPIs should be decided. KRAs and KPIs under the PMS, these can be fixed. There can be fixed number of KRAs like business goals, global standards, use of technology, and individual initiatives and the like. Each KRA should have associated KPIs, and managers rate subordinates on these KPIs that fall under these KRAs using a Likert scale 1 to 5 that can be used. KPIs, all KPIs defined for a role will include specific dimensions of the job or role of an employee and will cover the entire role. Their weightages can be attached to the KPIs. Weightages are to be assigned to, they can be attached to the KRAs also, that total up to 100 points. The highest weightage can be given to business goals. And they can also be attached to KPIs within a particular KRA, followed by less crucial KPIs. So less crucial KPIs should have lesser weightage. Self-rating and manager rating. The appraisal process should start with the self-rating done by every employee at the organization. Once the self-ratings are done, then the manager ratings take place. The manager is tasked with rating each of their team members of each of the KPIs on a 5-point Likert scale. Then this has to be integrated with the HRIS. The organization needs to integrate the PMS into the HRIS, conduct training sessions for line managers, bias mitigation training, or effective feedback like bias mitigation training. So managers should be trained on how to provide fair and objective feedback to their team members, and so that they can and they should avoid all kinds of biases. Effective feedback techniques should be used. Managers should be trained on how to communicate effectively, focusing on clear, actionable feedback that employees can use to improve themselves. Goal setting should be done, aligned with business goals, ensure that the performance objectives are directly connected to the organization's strategic goals and vision. Specific and measurable objectives should be fixed. smart objectives should be fixed. It is important to set objectives that are smart so that they can be measurable and they are quantifiable. So this is the performance evaluation criteria: goal setting, self-rating, and manager rating, one-to-one discussion. A scorecard can be maintained where you are defining the KRAs, the attached to that, and then the final rating is decided. So the conclusion of this study is that the HR needs to have a view of all the business functions in order to take part in important decision making. This alignment, when achieved, can greatly help performance assessments of teams and individual employees, and integrating L&D program with the aim to retain high potential employees and aid the low performing employees would greatly enhance workforce stability and efficiency of the organization. A well-designed PMS in association with a structured cycle of appraisal is the heart of such an initiative, providing a framework for continuous feedback, learning opportunity, and career development. There are certain implications also. The new PMS can be used by all organizations that seek to simplify their performance appraisal process. This PMS is designed to help the organization take further steps with regard to the retention of high potential employees and offer them growth opportunities. This new PMS ties up with the learning and development functions also. So PIPs can be worked out. An effective PMS has a very important implication. It can provide a strong background for the identification of high potential employees, planned time-to-time competency-based assessments and performance reviews can throw the spotlight onto sterling skilled employees with high leadership potential and significant organizational commitments. Such identification thus enables organizations to make focused investments in the development of future leaders. Thus, a well-defined performance management system will facilitate not only the identification of its high potential employees, but also in development and retention of such employees. Aligning performance assessments with opportunities for career development allows organizations to build committed forces that continue to flourish and maintain strength within the marketplace. Thank you.
Ma'am, is there any way that these appraisal systems you have customized for a particular domain of organization, or it is generalized for anybody?
It is generalized for everybody, because this study proposes that we should start from the objective, fix up the objective, organizational objective. From there, the team objectives, and then the individual's objectives will come. And the individual objectives should be in terms of KRAs, key result areas. Within every key result area, there should be KPIs, then there should be weights attached to it. And on the basis of that, the score should be worked out. If we go further deep into this paper, then we should have 80% target score, and we should also have 20% behavioral attributes. That should also be part of the overall performance score, because this paper is written on the basis of a study, so it involves that also, but that is not covered in this paper.
Okay, ma'am. Thanks.
Thank you so much. Thank you.
Thank you, ma'am. I'd like to call upon our next paper presenter. We have Nirmat Mawanji with the paper titled Misbehavior Detection Using Deep Learning in VANETs. So if you're ready, then you may start with the presentation.
Yeah, okay. Ma'am, it is visible?
Yes, sir, it is visible.
Good morning, everyone. Myself, Nirmit, and with my teammate Tejas. So we are going to explain about our paper misbehavior detection in VANETs using deep learning. So first of all, I'll say about the VANETs. So VANETs is nothing but a vehicle ad network, basically used in infrastructure intelligent transport system. Basically, it enables the vehicle-to-vehicle communication and vehicle-to-infrastructure communication, and it also enhances the basically traffic safety and some emergency response. So due to this, it has a high dynamic nature. Basically, expose some to harm cyber physical attacks, which includes like DDoS attacks, Sybil attacks, and some message falsification. So we have built a parallel MML CNN 1D framework. Basically, it compares the multi-layer perceptron with 1D convolution neural network, and it gives uh, misbehavior detection. And we have integrated a deep learning model with some explainable artificial intelligence like Sharp uh, to provide both high detection accuracy. So we have used a dataset called Wormy dataset. So our ultimate goal is to like enhance the security and transport system by detecting the malicious activities with high accuracy. So here are some requirements and design which you have used. Like there are like two categories, like functional requirements and non-functional. So in functional, like we have used a data set, we have load and we have normalized that, and we trained with ML models, and we are evaluated using some multiple metrics like confusion metrics and etc. And we have used like explainability, and we have stored these results as log. And some non-functional activities like high accuracy, classification accuracy, and some scalable model training, and good interruption, and easy productivity. So our high level design, which includes like data injection, pre-processing, and model training, evaluation, and explainability and output. So our methodology basically focus basically on two models. So which is like MLP model. So MLP model we have used because which it gives like internal representation of the data rather than giving a manual extraction of data, and it also gives like extracting like numerical features. So it includes like basically four layers. So first one is like railway activation model layer, which basically used to train faster and avoid the vanish gradient. And here we used like drop the point 3, basically deactivates the 30% of neurons you to prevent the overfitting. And uh, we have used Adam optimization as our data is highly dynamic to reduce the fluctuation and some speed mismatch. We have used that. Then we have used smart softmax function used to convert it to the binary classification. So we have trained using the 20 epochs with the batch size of 1000 to 4, and we have like 20% of validation split. And we have used like a CNN 1D model, basically used to get some local sequential patterns across the feature. So it also includes some layers like max pool layer and dense layer and conversion 1D model layer. So here we also use some early stopping to get the checkpoints to save the best performance weight. And so now then training strategy, we have included like both model adopt up the same training strategy. So first basically standardize the input, then we go with like 70-30 split, which includes like training 70% and 30% test split. Then we have used early stopping on validation loss with the best weight and restore. Then class weighting computing from the label sequence to mitigate the modern imbalance. And after this prediction, we have to get the result. We have used like compute metrics containing accuracy. We have used like precision, recall, and F1 score. And we use confusion matrix, which tells about like it's having a true positive, true negative. What's the result? And we have used like ROC curve and AULC curve also generated. Using that, we are getting the result. So here is the design which is told by my teammate Tejas.
Good afternoon, everyone. I'm presenting a work on misbehavior detection, which is vehicular ad hoc network (VANETs). VANETs are the backbone of intelligent transport system, but their decentralized nature makes them highly vulnerable to cyber attacks like DDoS attacks and civil attacks. So, to address this, we developed a parallel deep learning frameworks that prioritize the both detection and accuracy of the model. So we have the here we can see five blocks. One is data preprocessing layer. Basically, we use the WOMI dataset, which contains the approximately 22 million message logs of the benign and malicious behavior. So this layer performs a critical noise reduction and scaling to prepare the data for the specific input requirement of our further layers. So second one is the main base model, which is parallel modeling pipeline. We implemented a dual path approach to diversify our detection strategy. We used the CNN1D, which is convolutional neural network one dimension, to capture the local sequential patterns across the features, and baseline MLP model to learn the complex global features correlations. So these parallel structures allow us to compare the spatial feature analysis against the standard deep learning mappings. Then the third layer is evaluation block. This ensures us the fair comparison. All models are assessed using this unified set of matrices, including like accuracy, precision, recall, then ROC curves. So we utilized stratified 70-30% train test split of the dataset, which is 70% use it for the train and 30% of the dataset use it to test the dataset. Then we use the explainability AI, which is the key contribution of our work is solving the black box problem of AI by integrating SHARP, which is shapely additive explanations. We provided the transparency by ranking which sensor input, like speed or position, actually drive the detection of an attack. Means which features are influencing the attack more. Like that. So in the fifth layer, output and reporting, finally the system serializes the tiled weights for the deployment and stores the comprehensive visualization logs for auditing and further researchers. This is the architecture description as just said. So, yeah.
So
So,
next we come to the result and discussion. So here are some data statistics. Like we have here some Vermi data set of 22 million entries. So which includes no missing and duplicate values. Which basically like divides into attacks and normal message. And here are some dominant attacks like grid Sibyl attacks and DOS attacks, DOS distributed attacks, and DOS random attacks. So this here are some showing a correlation of the heat map, which includes like strong correlation between noise and clean feature and expecting relationship and speed and acceleration. So as a conclusion, the misbehavior detection is challenged because the attack and design samples are very similar. So as of now, we have got like performance accuracy almost to the 52%, and in MLP and CNN is 52.6. So we are basically both model perform only slight above the random 50% due to some high data complexity, as data is not sequential. So due to this, there is some like data set complexity and extremely feature difference. So we have this confusion matrix show the significance like false positive and false negative, and feature optimization were required for real world VANET deployment. And so here are some plots which have got through this. So here this is for MLP confusion matrix and CNN confusion matrix, and these are the graph curve of MLP and CNN of ROC. And here is a shape interaction which shows like how what are the red color basically shows about the greater the attack, and blue no attack is involved. So as the conclusion, we have this project basically tells about resolving the attacks to produce some robust detection framework, and we have implemented using parallel deep learning architecture, comparing the local feature attraction and global feature correlation using MLP. For the future, we are thinking of improving the accuracy and going with some different configuration of models to get the accuracy. Thank you. Hello.
Yeah, thank you, sir. Ma'am, would you like to ask any question? We'll be proceeding on with our next paper presenter.
Thank
I'd
you.
like to call upon, thank you, sir. I'd like to call upon our next presenter. One second. Vinod B. Maniat with the paper title Real-Time Detection of MQTT-based Botnet Attacks in IoT Networks Using Behavioral Analysis and Lightweight Machine Learning Models. Sir, if you're ready, then you may start with your presentation.
Yes, I am ready, madam. I'm going to share my slide now.
Sure, sir.
Good afternoon, all of you, all the participants, as well as chair. My project is a probe AED, the real-time edge native defense for MQTT IoT network. So we are three participants in this. One is Vinod Bhiman and myself, and Arun Kumar sir is my supervisor, and Shreyas is my friend. So first of all, we should know why we arrive at this. The MQTT trade-off, some of the difficulties we have in this protocol, MQTT protocol, we have some of the difficulties and problems. Efficiency at the cost of Explorer. So one is already existing models. We have lightweight models are these two. The MQTT is a backbone of IoT due to its a lightweight publish and subscribe model. And however, it relies on weak authentication and vulnerable topic namespace. So it is very weak when because we cannot send much more heavy software. So very weak authentication model we can implement in this because space and speed is very less. So the other problem is exploited from the stealth. Uh, stealth wildcard subscription model. Okay, on this wildcard subscription model that Ash and Plus are used. Hide botnet like Mirai and Mozi within legitimate traffic. Okay, so through when we are having a broker, we are the botnet attack can be possible by using this model. Okay, this is quite good than this, but there is a problem. Again, there is a problem with this. So the solution for this is one is having a too heavy model that is deep learning LSTM and CNN. High accuracy, actually CNN model provide very high accuracy, 96%, but a heavy footprint on 10 megabits RAM is needed and the latency is more than 400 millisecond. It is very difficult to implement in the small IoT devices. And static rule-based systems are very brittle, so it will not detect zero-day attacks, and it is behavioral drift, and so it is very difficult to keep that one. Okay, these two are the problem with the existing systems. So my system, we used a lightweight and it will achieve already a 4 MB and fast of less than 200 millisecond and adaptive to new threats. Okay, so this is the gap we identified and my system tackled this gap. So my system providing precision without a payload. Okay, we are not focusing on payload. Instead of we are focusing on behavior. Okay, I created a behavior model, so it will capture the behavior without getting enter into the payload. So real-time anomaly detector that secure MQTT network without inspecting encrypted payloads, preserving privacy while ensuring security. The memory footprint is less than 4 MB, fits on the standard microcontroller, and accuracy is 97.5 according to the F1 score, and the false alarm rate is 0.3%. So first packets flow will be analyzed. When packet comes, it will be analyzed, and it capture the behavioral drift engine will capture all the behaviors around 36 dimensions we are captured. Anomaly and classifier. I use anomaly classifier will classify which whether it is blocked or not. Okay, based on the behavior it exhibit. The speed is less than 150 millisecond. It will detect, and the classification time per 100 pockets in window. The resilient zero-day detection, DOS, Mirai, and Mozi variants also we can easily identify in this. So behavioral extraction process will work. A raw MQTT stream will be sent to this model. The feature extraction will takes place. The static protocol semantics, a QoS message type, and it will detect that one. Okay, only behavior, what are the available data. Okay, it will get the available data information. The temporal statistics also calculated by the model, and entropy indicators also create that one, and it will all capture the feature extraction. We mainly made it for feature extraction, and count means sketch probabilistic structure also give some data that will be stored in the vector. Okay, that vector. Okay. So multi-tiered adaptive ensemble, that vector is inputted to ensemble because we are used the ensemble ML algorithm. So we are using three here, each for a different kind. So one isolation forest is used for unsupervised detection. Naive Bayes is used for probabilistic classifier, and logistic regression is explainable decision. Okay, so all the three will give some value based on the detection according to the 36 inputs. So here we are using a weighted fusion, not simply we are go for soft voting or hard voting. Instead of that, we are used weighted fusion. So it will give the final verdict whether it is benign or malicious. Okay, based on the calculation, we will find. Okay. The actionable transparency with sharp. Sharp will be explainable algorithm. It will explain. It is not only detect. It will explain why it is detected as a particular thing. So workflow will be alert trigger on the edge devices. System calculate sharp value. Reporting highlight top influential features. Instant forensic justification. So topic burst. These all are the variations of the behavior pattern we are generated and we are extracted from the MQTT network. So QoS level and payload entropy, uh, inter-arrival variance, retain flag, and topic depth, and wildcard usage. Okay, these are features importance in sharp analysis. And sharp, based on this analysis, it will give the values, different values. From that value, we can easily analyze what for this is captured as the problematic or not. So adapting to a behavioral drift. The fixed threshold generate false positive as a legitimate network traffic pattern evolve naturally. The probe AD update its sensitivity threshold in real time. So this line is a threshold. above this line, whatever the variations we get in the load, it will be detected as mm, anomaly. Okay, that is so it will make the false positive. In this case, if anything is generated, it will consider false positive. The adaptive adjustment will be takes place. The dynamic threshold will be identified. Okay. Below this is a network noise floor. If most of the introducers are utilize the noise as their behavior, and it will enter into the network. So we will identify the noise here, so easily we can detect by using my system. So benchmark, I mean, we already existing. Some of the models are already existing. We used the CICIOT 2023 data. So benchmark, we are considered this one. So according to this, we compared with LSTM, autoencoder, and SVM. This is our ensemble. Okay, outperformed all the existing model. Okay, based on this data set. So we can see radar chart also. So it is showing the higher level efficiency on this. So it is validated on real world edge silicon. Okay. So Raspberry Pi and ESP32 and Jetson Nano. In these three, Jetson Nano shows a very good result in a very less time. It is responded, and it is detected the vulnerabilities. So in precision that reduces the alert fatigue. Impact on operations. False positive rate is only 1.5%. The security teams deal with actionable threat, not noise. So effective against DOS, Mirai, and zero-day variants. Okay, so these are some of the result. Okay. So research fragility, leave room from the application. Standard STM model will take, this is the one of the benefit. Mainly, it takes a 12.5 MB of memory, whereas ProVD will take only 2.2. Okay, we already seen. The power consumption is too less. Raspberry Pi takes 4.5 watt, and low power draw ensures battery viability for remote sensors. And the ultra low footprint allows the IoT device to run its primary application, sensor reading, action, alongside the security layer with degradation. So summary, so lightweight, okay, the system performed lightweight and less than 4 MB, a RAM running in ESP32, technical specs in JetBrains Mono, explainable sharp integration with human readable verdict, accurate 97.5, and F1 score on zero-day threat. The future decisions, the federated learning, secure gradient sharing without centralizing data, the adversarial defense, randomized smooth against poisoning, a protocol expansion, COAP, AMQP, and OPC UA support. The version secure the edge without compromising performance, the advancing autonomous self-healing IoT security. Technical specifications and hyperparameters. Feature dimensions, actually, we are collecting 38 features. So static, temporal, and entropy. Count means gauge 1000 into 5, 4K. Okay, just brain, it's a capacity of that EPS. The isolation forest, 100 trees are generated. Up to 100 trees it will generate. Naive base smoothing 0.05, and logistic regression 1, and learning rate is 0.01. The adaptive threshold decay is lambda. Okay, that is
Excuse me, sir.
0.
I'm really sorry to interrupt you, but I'd like to remind you of the time limit.
Okay, ma'am. End of this. Okay, these are the references. Okay, Kailash G A E T L 2025 Enhanced Intruder Detection System for using one Mamo Malmo Maria solution running Supreme. Okay, these are some of the latest papers available on this concept. So I referred all those things, and it all published in IEEE transaction and access journals. That's all. Thank you. Thank you for listening.
No comments, sir.
Okay, thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding ahead with our next paper presenter. I'd like to call upon our next presenter. Just a second. We have Ananya Arya with the paper titled Utilizing Reinforcement Learning for Noise Robust Fine Tuning of Whisper for Automatic Speech Recognition. Ma'am, if you're ready, then you may start with the presentation.
Yes, I'm ready. Just a second. Let me share the screen. Okay. Is my screen visible now?
Yes, ma'am, it is visible.
Okay. So, good afternoon, everyone. I am Ananya Arya, an undergraduate student from Indira Gandhi Delhi Technical University for Women, and I am honored to present our paper, Utilizing Reinforcement Learning for Noise Robust Fine-Tuning of Whisper for Automatic Speech Recognition, with the paper ID 677, authored in collaboration with Kriti Jain, Girisha Singh, and Professor Ritika Kumari. Okay, so this is the outline of the presentation in which we start with the introduction, inspect the literature review, find the resulted research gaps, further move on to propose methodology, went to results, and then conclude our paper with conclusion and future scope. Okay, so first let's start with the introduction. What is automatic speech recognition? It is a technology that enables machines to convert spoken language into written text. Now, ASR has made a tremendous growth around the globe. It has, and thanks to the large available dataset and deep learning methods. But still, in real life conditions, such as call centers, voice assistants, cars, there is a huge significant gap. What is due to? It is due to presence of noise, also known as Gaussian noise, which can be due to error in mic or anything like that. This leads to a huge gap and a significant decrease in word error rate. Now, when we further utilize and investigate about the available transformers, we come across one of the benchmark transformer, which is Whisper. Now, Whisper is developed by OpenAI and it is a multilingual ASR model. But again, Whisper also degrades its performance in presence of noise. So this study basically tries to bridge the gap between the performance. Now, this is the literature review. These all contain all the papers that we have used to understand the algorithms and understand that where we are lacking. So, firstly, we investigated low rank adaptation. Now, it is a type of PEFT model, parameter efficient fine tuning technique, in which we freeze pre-trained models weight and inject trainable matrices. Then again, we further investigated reinforcement learning. We have investigated reinforcement learning on other topics, and we have realized that it can be used for sequential modeling as present in the paper Decision Transformer Reinforcement Learning by Sequence Modeling. Next, moving on, we tried to investigate more variants of the algorithm, reinforcement learning algorithm that we have used, the advantage actor critic. So we have one of its variant, which is distributional advantage actor critic. Now, in this case, the computation cost was really high and it's not feasible to imply an all automatic speech recognition techniques. Next, we utilize few other papers to understand that most of the papers that is currently working in bridging gap and reducing the word error rate is mostly revolving around semi-supervised speech recognition, but they present a word error rate of 54%. So we tried to further reduce this word error rate. Now moving on to the research gap. So similarly, as mentioned, that the reinforcement learning has been unexplored in the field of ASR. Moreover, parameter efficient fine tuning will also help to fine tune these models, has also been unexplored to fine tune ASR transformers. This is the proposed methodology. Now here we have a data set which is Leapty speech. At this data set, we actually induce 3 level of Gaussian noise at the scale of 0.6, 0.06, 0.07, 0.08. Now we utilize our ASR transformer, Whisper. In Whisper, we actually did not change all its parameters. The reason behind it was because Whisper has around 244 million parameters, and such an updation will highly lead to first computation cost. Then Whisper can also lead. This can also lead to Whisper overfitting. Also, this can be a perfect case of catastrophic forgetting. Means that when we are training a specific transformer and changing its parameter based on new data, while we don't have the earlier trained data, a case of plasticity stability. Hence, we actually froze the entire layers, just left the last layer, combining it with parameter efficient fine tuning, and we have used its technique low rank adaptation for this purpose. Now, in parameter efficient fine tuning, we basically inject few trainable matrices in the last layer of the whisper so that no existing weight and parameters are affected. In this way, the model learns new data, learns new weights, but do not forget what it has actually learned. Moreover, it is computationally better as we are only training those weight matrices. Now, once we are done, we actually utilize our reinforcement learning algorithm, which is advantage actor critic. It is better than other reinforcement learning models, since in reinforcement learning, after the entire sequence is done, we actually understand that, okay, this is a correct approach. But in advantage actor critic, it is a two-way thing. Actor takes an action while critic try to understand and compute what will this action lead to, how much reward will it fetch. So in this case, we have used a negative word error rate as a reward model. So once actor takes an action, critic further utilizes and understand the entire situation and the actor actions, then it actually produce a score which has to be which has, according to it, will be a perfect score for this action. The score is and the reward is further finally computed, and whatever is the differentiation between the critic's score and the actor and the actual reward is actually the advantage. So after this, actor updates his policy and critic updates his prediction. Now we have utilized the performance metric of word error rate and character error rate to actually compare between actual working of whisper model in case of Gaussian noise and our framework, and then we have selected our best model. So this is the performance of the transformer, and as it is visible, and we can observe that our proposed model, which is Whisper A to C, has performed better than actually benchmark Whisper model at all the three noise level, with a significant decrease from 42.63 to 33.17 for the word rate and 24.17 to 21.63. Similarly, for 0.07 Gaussian level noise, it is a decrease from 43.04 to 41.31, 29.02 to 27. And similarly, for 0.08, it is from 58.12 to 51.32, 37.7 to 35.81. Here we have visualized the obtained result in form of pie chart, and we can see that this is our proposed model word error rate at different noise scale, and the actual benchmark whisper model word error rate in case of the Gaussian noise. So we further understand that our model has outperformed the benchmark model at all three different levels. As mentioned, at 0.06 we have a significant decrease from 42.63 to 33.17, and similar decreases in other noise level also, and for the character rate too. Now we further conclude this study by observing that our proposed model, which is a combination of a reinforcement learning algorithm advantage active critic, further combined with parameter efficient fine tuning using low rank adaptation technique to fine tune existing benchmark transformer model for automatic speech recognition, and they have shown a significant decrease in the word error rate. In the future scope, we are currently planning to further extend this to other reinforcement learning algorithms like PPO, soft actor critic. Moreover, further analyze and evaluate other parameter efficient fine tuning methods and work on more languages for the same. This is all. These are the references that shaped our study. And that's all from my side. Thank you for your attention, and I'm ready for any question.
All the best, Ma.
Thank you. Thank you. Shall I stop sharing my screen?
Yeah, ma'am, you can stop sharing your screen. I'd like to once again ask for Ma'am Preeti, if you're available, then you may start with your presentation.
Yes, ma'am, I am available, and I'm
Yeah,
starting with my presentation, sharing my screen.
sure, ma'am.
Ma'am, my screen is visible?
Yes, ma'am, your screen is visible. Please go ahead.
Okay. Good afternoon, everyone. Today I'm presenting my paper on the topic E-Governance for Sustainable Industrial Development and Evaluation of State Policies in Uttarakhand. My paper ID is 581, and I am from Graphical deemed to be University, Dehradun. My co-authors are Dr. Rupa Khanna Malhotra, Ms. Mani Preeti, Ms. Shruti Sharma, and Dr. Shipra Gupta. We are from Graphical University and Graphical Hill University. So today we are presenting the topic of e-governance. E-governance is defined as the use of information and communication technology which improves public accountability, facilitate effective service delivery, and decrease bureaucratic delay for the industries. E-governance is serving as the backbone for sustainable industrial development in Uttarakhand. In this paper, I have focused on how digital policies are not just making business easier, but also making it greener and more inclusive. Like Uttarakhand scores only 62 out of 100 on SDGs, which suggesting a gap in the efficiency of industrial strategy. Despite Uttarakhand is having a very good score, total score of 79 out of 100 in the SDG India Index 10 of 2023-24. So in this paper, we have taken different policies of the government and we have mapped them with SDG 9. And we have also discussed about the key features and major incentive provided by these policies. Further, the fiscal benefits and the digital workflow, which is a single window clearance system, is also being taken up in the paper. Like the state is currently on a mission which is known as Sashakt Bharat. Now, with the goal to double the state's economy, it's about nearby 4 trillion rupees. To do this, the government has moved beyond simple online forms to comprehensive digital ecosystem, which is known as the single window clearance system for the industries, to include the paperless laws and to launch the AI mission. Now, to prove that to examine or to prove whether governance digitization actually translating into improved sustainable outcomes in industrial sector or not, we have structured or we have studied the e-governance system. And for this, the research methodology used is we have restricted the data from secondary sources and we have taken out some of the variables of growth to measure the relationship between these two. Like these are the variables which are being studied and the data sets are being taken from the official government sources such as Niti Aayog and SDG India dashboard, IBEF states profile. From the data extracted from these different official sources, key variables are taken from the year 2018 to the year 2024. Variable considered, we have taken both the eras. We have done comparison of post COVID and pre-COVID also. We have included that one topic also in the paper. Variable considered are these are the variable considered like SDG 9 is score of the because SDG 9 is on industry innovation. So that's why we have included this in our paper. E-service deployed manufacturing share of gross state domestic product, unemployment rate, and FDI inflow. So we have studied basically the impact of e-governance on all these variables. And while analyzing the mean standard deviation and further, we have also studied the correlation. So while analyzing the correlation in between e-service deployment and the different development indicator, it has been observed that all indicators are having a very strong relationship with e-service deployment, which shows that facilitating users with these services help in the development of state. The exceptionally high correlation between e-services and SDG 9. It reveals it's almost 0.99 that expanding digital governance infrastructure is very closely associated with improved sectorial sustainability performance. Like a strong negative relationship with unemployment rate indicates that it is linked with labor market and its improvement. Like labor conditions are also improving. SDG score is also increased of the state from 48 to 62 in these last 7 years. Number of e-service deployed is also increased. In percentage, it is 180.59, although in the numbers, it's 340 to 954 in numbers. Share of manufacturing sector is also increased. The growth rate is here 29.17. SG9 scores, if we'll talk about 48 to 62, it increased in percentage 16.18%. Overall, SG inflows FDI, foreign direct investment, also increases, and there is a further increase of unemployment reduction also. So to test whether expanding e-governance produced have significant results over SDG 9 improvement rates or not, again SDG patterns are studied, which reveals there is a slowing trend in the year 20 and 21, while because of COVID and the acceleration becomes from the year 22, which shows that COVID after initial system deployment when it starts materializing. Now to check comparison between pre and post COVID on SDG 9 results further, p-value has been calculated, which is 0.0126 and it is less than 0.05, which again shows a statistical good performance, improved performance after the post-COVID-9. This reveals that there is a significant relationship between the growth of industries and e-governance structure in the state. Now, data further finds that e-governance rapid expansion correlates with improved government outcomes, yet there is a weak direct linkage and substantial implementation gap. Implementation gaps are in the form of mountain versus plain gap. While district hilly areas, they have 85% of adoption rate. The higher altitude hill areas, they are having only about 58% adoption rate. And this is not just about lack of internet, it's about the upgrading, use, technology. These all are being covered in detail. This digital divide is the primary reason why, because of which 90% of the industries, they are still concentrated in plain areas, not the hilly areas. So, state is demonstrating limitations as well as potential of governance digitalization for sustainable industrial development. E-government infrastructure has expanded substantially and high degree of correlation with development indicators. Further tests suggest that post 2021 there is an expansion of e-governance systems. However, there is a gap between e-governance deployment and SDG performance growth rate, which reveals that technology is not only sufficient, but there is a need of institutional awareness and innovation, which will include data integration, stakeholder coordination, even in the rural areas and villages for making it easy to use. Now, to move it further or to improve it, there is a need for implementation of the different projects from the side of the government. In the hilly areas also, there should be technical availability so that this hill and plain divide could also be built up. Thank you. May I stop sharing, ma'am?
Yes, ma'am, you can. Thank you, everyone. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days. Furthermore, the publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM 2026. Uh, Before I end the session, I'd also like to thank our session chair for chairing this session. Talking to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. Just before we end the session, I'd like to request everyone to turn on the cameras for a quick snapshot of the virtual conference. Thank you, everyone.